The world of mathematics is full of wonders. Speak your thought, walk your talk, and make these wonders a reality. Good day, grade 11 students. Welcome to this episode of Pre-Calculus for Quarter 1. This is Sir Jeff, your guide as we journey to an exciting and amazing world of pre-calculus. And to all grade 11 students, just relax, enjoy, and appreciate the beauty of mathematics.
For this episode, you will be learning about the series and sequences. At the end of the lesson, you will be able to illustrate a sequence and a series, construct a mathematical expression to represent sequence and series, and solve for the unknown term of a sequence and sum of a series.
Before we begin our discussion, let's start with a short activity and see if you are ready for our lesson.
Answer the following questions. Use a piece of paper to write the letter of your answer. Number 1. The following are examples of a finite series, except which one? A. 0, plus 2, plus 4, plus 6, plus 8, plus 10. B. 1, 4 thirds, 5 thirds, 2, 7 thirds, 8 thirds, 3. C. 1 half, plus 1 third, plus 1 fourth, plus 1 fifth, plus 1 sixth, plus 1 seventh. And letter D. Negative 1, plus negative 2, plus negative 4, plus negative 8. The correct answer is Number 2. What is the next term in the geometric sequence 4, negative 12, 36? A. Negative 42. B. Negative 54. C. Negative 72. And letter D. Negative 108. The correct answer is Number 3. Given the function s of n equals 3n plus 2, what is the 12th term of the sequence? A. 25. B. 43. C. 38. And letter D. 52. The correct answer is Number 4. What is the sum of the infinite geometric series 3/4 plus 9 over 16 plus 27 over 64 plus 81 over 256 and so on? A. 3. B. 3 over 7. C. 3/4. And letter D. 1. The correct answer is And number 5. What is the sum of the first 56 terms of an arithmetic series, whose first term is 4, and the last term is 108? A. 3035. B. 3156. C. 3136. And letter D. 3561. The correct answer is
How many correct answers did you get? If you got a perfect score, that's great. But if not, don't worry, because I will be here to guide you as you explore and discover the lessons in this episode.
Cup stacking is a popular game, where plastic cups are stacked into a pyramid pattern. The sequence used for this trick is having each layer of the pyramid a 1 cup less than the lower layer. As shown in the picture, there is a series of 15 cups used for this pyramid pattern. But what do we mean by series and sequence? A sequence is a succession of numbers in a specific order. Each number in a succession is called a term. The terms are formed according to some fixed rule or property. They are arranged as the first term, second term, third term, and so on. And when we say series, it represents the sum of the terms of a sequence. To get familiar how sequence and series look like, a sequence is basically a list of numbers separated by commas, while series is a sum of numbers separated by positive or negative sign. How many terms can be used in a sequence? If the number of terms in a sequence is defined, we call it a finite sequence. And its associate series is called the finite series. But if the sequence has infinitely many terms, we call it an infinite sequence. And its series as the infinite series. To illustrate this, a sequence with nth term, s sub n, is usually denoted by the set of numbers, s sub 1, s sub 2, s sub 3, up to s sub n. And the associated series is given by s is equal to s sub 1 plus s sub 2 plus s sub 3 up to s sub n. Let's have an example. Determine the first 5 terms of the sequence defined by the expression 2 minus n, and give its associated series. To solve this, we will represent the 5th term of the sequence by a sub 5. And the series by s equals a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. To get the first 5 terms, we will substitute the values of n to our equation, a sub n equals 2 minus n. For the first term, the value of n is 1. Substituting this to our equation, we get a sub 1 is equal to 2 minus 1, which is equal to 1. For the second term, the value of n is 2. Substituting this to our equation, we get a sub 2 is equal to 2 minus 2, which is equal to 0. For the third term, the value of n is 3. Substituting this to our equation, we get a sub 3 is equal to 2 minus 3, which is equal to negative 1. For the fourth term, the value of n is 4. Substituting this to our equation, we get a sub 4 is equal to 2 minus 4, which is equal to negative 2. And for the fifth term, the value of n is 5. Substituting this to our equation, we get a sub 5 is equal to 2 minus 5, which is equal to negative 3. There you have it. The first 5 terms of the sequence. Now, let us solve the series. As mentioned a while ago, its associated series is given by s equals a sub 1, plus a sub 2, plus a sub 3, plus a sub 4, plus a sub 5. And using the first 5 terms we solved recently, we simply add them. Hence, we get s equals 1, plus 0, plus negative 1, plus negative 2, plus negative 3. Or, we can rewrite this as 1, minus 2, minus 3. And the final answer is negative 5. Therefore, the value of the series is negative 5. There are different types of sequences and their corresponding series. We have arithmetic sequence, arithmetic series, geometric sequence, geometric series, and infinite geometric series. We also have this special type of sequence called the Fibonacci sequence. Let's begin with Fibonacci sequence. Fibonacci sequence was first discussed in Europe in the early 13th century. The proponent is an Italian mathematician named Leonardo of Pisa, whose nickname was Fibonacci. It was named after him, although the sequence can be traced back to about 200 BCE in Indian literature. What is Fibonacci sequence? Fibonacci sequence is a sequence where the two consecutive previous terms are added to obtain the next term. The same rule is applied to get the succeeding terms of the sequence. An example of Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, and so on. As you can see, the first two terms are 0 and 1. Adding these two consecutive terms would get the third term, which is 1. Adding the second and third terms 1 and 1, would get the fourth term, which is 2. And following the same procedure will obtain the next succeeding terms as shown in this example. The next type of sequence is what we call arithmetic sequence. Arithmetic sequence is a sequence in which each term is obtained by adding a constant called the common difference. To find the nth term of an arithmetic sequence, the formula to be used is a sub n equals a sub 1 plus the quantity n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference. Let's have an example. Find the 12th term of the arithmetic sequence, negative 4, negative 1, 2, 5, 8, and so on. By analyzing the sequence, each term is added by 3, to proceed to the next term. So, the common difference is 3. And since we are concerned with the 12th term only, our n is equal to 12. The first term a sub 1 is also given, which is negative 4. If we substitute these values to the formula, the solution is a sub 12 equals negative 4, plus the quantity 12 minus 1, times 3. Evaluating the terms inside the parenthesis, we have 11, and multiplied by 3. That is 33. And, negative 4 plus 33 gives us, positive 29. Therefore, the 12th term of the given arithmetic sequence is 29. If there is an arithmetic sequence, there is also the sum of its terms. And that is what we call the arithmetic series. The sum of the first n terms of an arithmetic series can be solved using these formulas. Take note of this. The first formula is used when the first term, the nth term, as well as the number of terms are all given, but the common difference is not given. While the second formula is used when the first term, the number of terms, and the common difference are all given, but the nth term is not given. You can use any of these two formulas depending on the situation of the problem. Let's have an example. Find the sum of the first 10 terms, given the following. Number 1. The first term is 5, and the 10th term is 68. And number 2. The first term is -1, and the common difference is 6. For problem number 1, the given are, the first term, and the 10th term. From these given, we can use the first formula to solve the series. Hence, the solutions are. Therefore, the sum of the first 10 terms is 365. For problem number 2, we have the first term and the common difference. For this problem, we will use the second formula to solve the series. Hence, the solutions are. Therefore, the sum of the first 10 terms is 260. Another type of sequence is what we call the geometric sequence. Geometric sequence is a sequence in which each term is obtained by multiplying the previous term by a constant called the common ratio. To find the nth term of a geometric sequence, the formula to be used is a sub n equals a sub 1 times r raised to n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Let's have an example. What is the fourth term of a geometric sequence, if the first term is 8, and the common ratio is 3? To solve this, we will use the formula and substitute the value of the first term, which is 8, and the common ratio, which is 3. Hence, the solutions are a sub 4 equals 8 times 3 raised to 4 minus 1. First, we evaluate the exponent 4 minus 1, which will become 3. 3 cubed gives us 27. And finally, 8 times 27 is 216. Hence, the fourth term of the geometric sequence is 216. Let's have another example. Find the 11th term of the geometric sequence, -40, 20, -10, 5, and so on. In this problem, we need to find first the common ratio used in the sequence. It must be a constant that was multiplied to the first term, -40, in order to get a product of 20, which is the second term. To do that, we simply divide 20 by -40. Therefore, the common ratio is -1/2. And since the first term is -40, and there are 11 terms in the sequence, therefore, the 11th term can be solved by substituting these values to the formula. First, simplify the exponent, 11 minus 1, which is 10. Next, evaluate -1/2, raised to 10, and that is positive 1 over 1024. And finally, multiply it by -40, and the final answer is -5 over 128, in lowest term. Just like the arithmetic series, the terms of a geometric sequence can also be added, which will form into a finite series called the geometric series. The sum of the first n terms of a geometric series can be found using this formula. S sub n is equal to a sub 1 times the quantity r raised to n minus 1 all over r minus 1, where a sub 1 is the first term, r is the common ratio, and r is not equal to 1, and n is the number of terms. Let's have an example. Find the sum of the first 6 terms of the geometric sequence, 3, -6, 12, and so on. The common ratio for this sequence is the quotient when the second term is divided by the first term. And that is -6 divided by 3, which is equal to -2. Since the first term is 3, and there are 6 terms, therefore, the sum of the first 6 terms of the geometric series can be found by solving this. First, we evaluate -2 raised to 6. And that is positive 64. Next, we subtract 64 by 1, which is 63. And, using division property, 3 divided by -3 is -1. Multiply it by 63, and the final answer is negative 63. The examples we discussed are all about finite sequence and series. And, for the last part of our discussion, let's talk about the infinite geometric series. Here is the formula used to find the sum of infinite geometric series. Let's have an example. Find the sum of the infinite series, 16, plus 8, plus 4, plus 2, and so on. In this series, the first term is 16, and the common ratio is the quotient of 8 and 16, which is 8 over 16, or 1/2, in lowest term. By substituting these values to the equation, we get 16 over 1 minus 1/2. Evaluating the denominator, we get 1 minus 1/2, or 1/2. Next, we divide 16 by 1/2 using reciprocal. That is, 16 times 2 over 1, or simply 16 times 2. And the final answer is 32. Hence, the sum of the infinite geometric series is 32. Identify the given series. On your paper, write AS, if it is an arithmetic series. GS, if it is a geometric series. And IGS, if it is an infinite geometric series. Number 1. 10, plus 2, plus 0.4, plus 0.08, and so on. The correct answer is number 2. 4, plus 9, plus 14, up to 64. The correct answer is number 3. 81, plus 27, plus 9, up to 1 over 81. The correct answer is number 4. Negative 10, minus 2, plus 6, up to 46. The correct answer is and number 5. 1, minus 0.1, plus 0.01, minus 0.001, and so on. The correct answer is for activity 2. Find the missing terms in each of the following sequences. Number 1. Find the next 3 terms of the arithmetic sequence, 3, 12, 21. The correct answers are number 2. What are the 2 missing terms of the arithmetic sequence, 2, blank, 20, 29, blank? The correct answers are number 3. Find the next 3 terms of the Fibonacci sequence, 3, 7, 10, 17, 27. The correct answers are and number 4. What are the next 3 terms of another Fibonacci sequence, -9, 5, -4, 1, -3? The correct answers are Did you get a perfect score? If yes, that is great. But if not, you can still participate in the next activity. This time, let us solve a real-life situation problem related to the topics that we discussed. A billionaire decided to celebrate his birthday as Thanksgiving by donating 1 peso on the first day of December, 2 pesos on the second day, and on every day that follows, up to 24th of December, to a charity group that helps indigenous people of the local. The donations formed a geometric sequence, 1, 2, 4, 8, and so on. What is the total amount of donations on December 24? Let us check your answer. From the given geometric sequence, the first term is 1. The common ratio is 2, which is the quotient when a term is divided by its previous term. Here, we can say that the second term, 2, is divided by the first term, 1. And the number of terms in total is 24. Using the formula of sum of geometric sequence, or geometric series as we call it, we simply substitute these values to the formula. First, we evaluate 2 raised to 24, as well as the denominator, 2 minus 1. 2 raised to 24 will become 16,777,216. And the denominator will become 1. Since the numerator has a factor of 1, we can simply cancel 1 over 1, using division property. Finally, we subtract 16,777,216 by 1, and the final answer is this. Hence, the total donations on December 24 is 16,777,215 pesos. After some practice and problem-solving activities, let us summarize all the concepts you learned so far. Complete the following statements by providing the correct word or words. Blank is a succession of numbers in a specific order. Each number in this succession is called a term. The terms are formed according to some fixed rule or property. On the other hand, blank represents the sum of these terms in the succession. The correct answers are blank is a sequence where 2 consecutive terms are added to obtain the next term. The same rule is applied to get the succeeding terms of this sequence. The correct answer is blank is another type of sequence in which each term after the previous is obtained by adding a constant called the common difference to the previous term. The sum of this sequence is called blank. The correct answers are Blank is also a sequence in which each term after the previous is obtained by multiplying the previous term by a constant called the common ratio. The sum of this sequence is called blank. If the sum of this sequence has infinite number of terms, it is called blank. The correct answers are Our session is almost over. But before we end, let us measure the knowledge and skills you learned from what we discussed in this episode. By doing so, we can also test if you met the learning objectives we gave before the lesson began. Read each question carefully. On your paper, write the letter of the correct answer. Good luck, students! The correct answers are
Congratulations, grade 11 students! You have completed all the activities from the lesson in this episode. Hopefully, you have learned a lot and put all your acquired learnings into practice by exploring this beautiful subject, pre-calculus. Once again, I am Sir Jeff. See you on more exciting episodes, only here on Puerto Princesa Dream TV.